Hello students, in this video we are going to solve a numerical based on Kirchhoff voltage law, right, and Kirchhoff current law. The question given here is two batteries of 7 volt and 13 volt and resistances of 1 ohm and 2 ohm respectively are connected in parallel with the resistance of 12 ohm. Find the current through each branch of the circuit and potential difference across 12 ohm resistor. If we observe this circuit diagram, two batteries are provided here, one battery of 7 volt and another battery of 13 volt, right. Now each battery has its internal resistance. 7 volt battery has internal resistance of 1 ohm and 13 volt battery has internal resistance of 2 ohm. Also there is external resistor attached in the circuit is of 12 ohm, right. What we have to find? We have to find the current through each branch, that is value of I1 and I2 and the potential difference across 12 ohm resistance, and we have to find the potential difference across 12 ohm resistance. While solving this numerical, we have to use the Kirchhoff voltage law, which says algebraic sum of the potential difference, which is product of current and voltage and electromotive forces, is 0. If we use this formula, if we use this law, what we have to consider? We have to consider the current which is flowing through the circuit and the EMF, that is battery used in the circuit, right. To solve this equation, we have to consider two loops in the circuit, right. The first loop that we can consider here is loop which is starting from point A and ending at the same point, right. And the second loop we will consider from consider the loop starting from point C. The first loop that we are going to consider here is loop A, E, F, D, B, A. This will be the first loop, that is A, E, F, B. The loop that we are going to consider here is A, E, F, B, A. We have to use this Kirchhoff voltage law for the loop. Now for the first term, that is product of current and resistance. In this loop A, E, F, B, A, the resistor attached here is of 12 ohm and through this resistor the current flowing is I1 plus I2 and the another internal resistance of 1 ohm and the current flowing through this resistor is I1. So let's write, through the 12 ohm resistance current flowing is I1 plus I2 and through the resistance of 1 ohm current flowing is I1. Now the second term, that is electromotive force. For this loop A, E, F, B, A, the battery used here is of 7 volt, but according to the rule, within the source, if the direction of loop is from negative terminal to the positive terminal, EMF will be taken as positive. So therefore it will be 7 volt is equals to 0. Now let's look for the sign for this potential difference term. If the direction of loop, first we will let's remove all this to understand the circuit diagram very well. For the first term, that is current which is flowing through 12 ohm resistance is I1 plus I2. Now let's look at the direction of loop and current. In this loop, direction of loop and direction of current are in same direction. Therefore, sign will be negative. Second resistance, that is 1 ohm, through this direction of loop and direction of current, this direction, both are in same direction, therefore we will use minus sign. Now next step will be 12 in bracket I1 plus I2 plus I1 is equals to 7. If we open this bracket, it will be 12 I1 plus 12 I2 plus I1 is equals to 7. There are two terms of I1, that is 12 I1 plus I1. It will be 13 I1 plus 12 I2 is equals to 7. Let's name this equation as equation number 1. Now the second loop that we are going to consider here is this loop C, E, D, C, right. Let's write the loop, that is C, E, F D C. Again we have to use this formula for the loop. We will remove this previous sign. In this loop 12 ohm resistor is used. Through this resistor current I1 plus I2 is flowing. Another internal resistance of the battery of 2 ohm, through this current I2 is flowing, right, and battery of 13 volt is used here. So let's write this term. Through the 12 ohm resistance current flowing is I1 plus I2. Through the 2 ohm resistance current flowing is I2 and battery of 13 volt is used, and sum of all these terms will be 0. By using sign convention, if we look here, direction of loop and direction of current is same, therefore sign will be minus. Here through the 2 ohm resistance direction of current and direction of loop same direction, therefore it will be minus sign. Now for this battery, if we use the sign convention for this, for the electromotive force, if within the source direction of loop is from negative to the positive terminal, we consider the sign as positive. Let's simplify this equation. It will be 12 in bracket I1 plus I2 plus 2I2 is equals to 13. If we open this bracket, it will be 12 I1 plus 12 I2 plus 2 I2 is equals to 13. There are two terms of I2, hence this equation will be 12 I1 plus 14 I2 is equals to 13. We will give this name as equation number, we will give this equation as equation number 2. Now our next step will be to subtract equation from each other. What we can do? We will subtract equation 1 from equation 2. So let's write first equation number 2, that is 12 I1 plus 14 I2 is equals to 13. First equation is 13 I1 plus 12 I2 is equals to 7. We have to subtract it. 12 minus 13, it will be minus I1. 14 minus 12, it will be plus 2 I2 is equals to 7. Sorry, it will be 13 minus 7, it will be 6. Hence value of I1 is 2 I2 minus 6. Here we get the value of I1. Now what we have to do, next step will be, we have to use the value of I1 in equation 2. So let's substitute this value. If we substitute the value of I1 in equation 2, the equation will be 12 in bracket 2 I2 minus 6 plus 14 I2 is equals to 13. Hence it will be 12 into 2, it will be 24 I2 minus 12 into 6, it will be 72 plus 14 I2 is equals to 13. Hence the equation will be, we will add these two terms, that is 24 plus 14, it will be 28 38. So it will be 38 I2 minus 72, it will be 13 plus 72, that will be 5 8, it will be 85, right. Therefore value of I2 will be 85 upon 38. We got this value of I2. If we use log table, what will be its value? If we use log table, its final answer will be, if by using the log table, its final answer will be 2.237 ampere. This is the value of current which is flowing through the 13 volt battery, right. This is the value for current which is flowing through the 13 volt battery. From this value we can find the value of I1. So this I1 is equals to 2 in bracket value of I2 we can directly take it as 85 upon 38 minus 6. Its final answer after calculation is coming as minus 1.526 ampere, right. So the value of I1 current flowing through 7 volt battery is minus 1.526 ampere. First value that we got for I2 and the second is I1. What we have to find? Find the current through each branch. Now the current which is flowing through this branch is minus 1.526 ampere and the current which is flowing through this branch is 2.237 ampere. So what will be the addition of these two currents which is flowing through the 12 ohm resistance? Let's add this. I1 plus I2, it is equals to minus 1.526 plus 2.237. Therefore, the current which is flowing through the resistance 12 ohm, that is I is equals to I1 plus I2, it will be 0.711 ampere. This is the value of current which is flowing throughout the circuit. What next we have to find? We have to find the potential difference across 12 ohm resistance. This 12 ohm resistance, what will be the potential difference across its two terminals? Which formula we can use? By using Ohm's law, that is V is equals to IR. The value of current that we got is 0.711 ohm, 0.711 ampere, and the value of resistance is 12 ohms. Therefore, potential difference across 12 ohm resistance, it will be 8.532 volt, right. So while solving this numerical, what we have done? First we have understand the direction of current, the resistors attached in the circuit, the battery and its internal resistance, and this Kirchhoff voltage law. We have considered two loops, right. For the first loop we have applied the Kirchhoff voltage law. For that we have given it as equation number 1. For the second loop we have again applied the Kirchhoff voltage law. We have given this as equation number 2. So by subtracting these two equations, first and 2, we got the value of I1. So what we did next? We put the value of I1 in equation 2. From this we got the value of I2. Similarly, magnitude, we got the magnitude of I2 and then value of I1. So what we did? We add these two currents which is flowing throughout the circuit and we got this final value. And by using this value of current which is flowing through the 12 ohm resistance,